right, so I've been given the green signal to start, so I'm going to start. Hi everyone, my name is Rutu Mulkar, and I'm going to talk about managing machine learning experiments. So if you guys are here, I'm assuming you do some amount of machine learning on a daily basis. How many people do machine learning? Okay, 4 people. Okay, great. How many people do dev work and are interested in ML? Okay. What about you guys? Like, what brings you to the machine learning talk? Just interest?
I'm a UX person and I'm doing my research about designers' experience with cloud-based tools.
Mm-hmm.
So I'm attending and learning about all these different things.
Okay, UX person interested in ML and looking to use ML tools for future work. Any other use case that brings you here? No. Okay, that's good. So a little bit about me. I have a background in computer science. My PhD thesis was in natural language processing. And I've been running this AI company called Tikeri Solutions for 5 years that I recently sold to Sigmoidal. I've been a contributor to IBM Watson that defeated humans in Jeopardy. This was back in 2010. And I've worked at larger companies like PwC and IBM, and also smaller companies like Moz and Precise Healthcare, which is a healthcare company for managing health data and doing ICD-9 coding. In this talk, I want to talk about a few things in the ML space, things that we have gone through, and there isn't quite a centralized, unified way to solve. First, I'll talk about a typical machine learning pipeline that we all follow to train models and to test models and to evaluate models and to deploy models. Then I'll talk about how we are actually managing our machine learning experiments. How do we reproduce? How do we track? How do we score and evaluate? Then I'll talk about how the ML workflow is not quite like the software engineering workflow, although we use the same tools. We use Git for source control. We use, the same data repos. Some tools to manage ML better. And this is more about bringing information from software engineering into ML so that we can write better code for machine learning. Finally, how do we actually track our ML experiments? There are lots of open source tools out there that we can just use off the shelf and have our experiments readily reproducible, readily trackable for our own self. Once you're done with open source, there's paid tools that you can use. None of them have quite become, the monopoly or the incumbent, but they are still a step up in our own workflow and how we want to go about things. So if you're on your laptop and if you don't want to ask questions directly, feel free to type in your questions here. As we are a small crowd, I'd love to be interactive. So if there's something that you want me to explain, or a question or something that you say, this just doesn't make sense, please stop me, please talk to me. I'd love to kind of address it as we go along. And finally, the conclusion. So first, let's talk about a typical machine learning pipeline. So consider this scenario. I'm coming from an NLP background, so my examples would be about language. I hope you can still, if you have questions about it, please feel free to stop me. So you're a data scientist. You're provided with 10,000 samples of conversation data. And you're asked to build a classifier that says, given this sentence, what type of sentence is it? It's classified by an intention. So here's a sample corpus. Oversimplification, but for example purposes. There are 4 sentences or 4 questions. What time is it? Can you tell me the time? Set an alarm for 8 p.m. Can you remind me at 8 p.m.? And so there are 2 intents. There's a red intent where it's about asking time, and then there's a green intent which is about setting a reminder, setting an alarm, right? And now your job is to build this classifier that will automatically discover what is red and what is green. Now as a human, you start with, well, let me just build something quick. Let me write some code. So you write some code about it to figure out what is intent 1, intent 2, and it typically looks like this. It's not very interactive. It's a blob of code, but you have an idea of what would capture your data really well. And you test it on a small sample of data, which gross oversimplification is those 4 sentences as opposed to 400 or 4,000 sentences. If it doesn't work, which usually it doesn't because there's a bug in your code somewhere, and you fix it. You write that code again, and hey, it works. So what's the next step? Well, you increase your data size. Instead of those 4 examples, you start with 400 or 4,000 and see how that works. It works, but this is not the best model, right? It cannot be the best model. It works on those 4,000 sentences. So you iterate, and you try to find the best model by changing a bunch of things. You could change the algorithm, you could change the hyperparameters. If you're doing deep learning, you could change the architecture. You could use some off-the-shelf architecture that you just read a paper about, and there's a beautiful GitHub link of that. But this is a very iterative process, and it's a black hole that sucks us in for days or weeks or months. But at the end of it, you find that model, and you deploy it into production. Hooray, it works. For a little while till you figure out it doesn't address a bunch of cases, and then you go back again to do that. So this talk is about this yellow circle. It's about how do we figure out how to manage all of our iterations. We don't really do that, right? It's an ad hoc process. So far, what we do is we use GitHub or some GitLab or some kind of source control that stores all of our code. And we can do git commits and commit everything. We could tag a certain branch to say, well, this branch worked. And that's how we're managing most of our machine learning code. We have some sort of file control, and there is still some more work to be done here because we don't have really good version control of data. But if your data, assuming in this case, is relatively static, that means it's not changing. It's not like Amazon is getting new reviews every week, so their model for predicting things changes every week. Assuming your data is very static and that data isn't changing. So you're using the same files. And we have platforms like AWS and GCP and DigitalOcean and a bunch of others which can help us deploy our models into production. So we don't need to worry about downtimes and concurrency and all of those other things which we had to worry about before. But what is not quite handled is this yellow circle. And how complicated is this yellow circle? What is the stuff that we need to do in order to track our experiments? Well, in this specific case, one might start with, let me do a simple model where I'm manually figuring out what the features are. So you add different types of features to your code. A simple feature would be a keyword like time is a good feature. It's a Boolean feature. I can have time is 1, time value is 0, and times value is 0. Because there's no presence of the word time here, there's no presence of the word time here. There's a presence of a word time and time here. So a simple, very simple classifier would be to use this. You could say words like reminder and alarm are for the green class, right? It's a very simple classifier where we have a vector of size 3, where the first is time, the second is reminder, and the third is alarm. That's super simple. What if you had different variations of the word time, right? What would you do then? Well, there's this cool thing called word2vec, where anybody not familiar with word2vec? Okay, so word2vec is a model that has vectorized most of the English keywords and so word2vec is an algorithm. I want to take that back. But there are trained models based on that algorithm that models entire English vocabulary. And because of that, we can do mathematical operations on keywords. Things like words similar to time. What are the other words similar to time? And I have a link here, which I don't know if I can open.
So word2vec models, I cannot miss that. Models, what does it model?
It is a model, it's a vectorized model of language and words of the world. So using that, we can do mathematical operations on word2vec. Actually, surprisingly, last talk that I talked at right here 4 years ago was about word2vec. It's funny that we're coming back to that today. But the reason I bring that up is we don't need to build an entire dictionary of words similar to time. We can use word2vec, take the top 5 words similar to time, where we get something like day and month and year, which is good enough. We don't need to build that dictionary. But in order to scale our original assumption and original idea of using these keywords, we can do that. Other things we can do, well, we can use scikit-learn and use n-gram vectorizers. What that means is using single words, using 2 words, 3 words, n grams, which means how many grams do you want in a vectorizer. You can actually code that in and brute force your way in to see, without any upfront semantic knowledge investment, which means you're not providing it any information about time, words like time and words like alarm and remind, because they are much more semantic, they are much more human knowledge. You are asking it, based on the way words occur with each other, can you predict how my system would go? So just in this ideation phase, we figured out 4 different feature types. Then we can change the algorithm. We can say, well, I want to come up with a baseline, which is a naive Bayes algorithm. And then you want to change it up and say, random forest is pretty good because it's an average of so many different decision trees. So let me just try and use random forest. Other people who just figured out, hey, RNNs are great. There's this new paper that I read, and with certain hyperparameters, it performs really well on this kind of data. So now we're into this deep learning world. And then we can, once we figure out which combinations of these we need, we change the hyperparameters. We change it in, in TF-IDF vectorizer, we can change the number of words, number of characters, we can change the size of the n-grams, and we can change a bunch of other things, which is way more common in the deep learning space. Finally, pipeline changes. This is not trivial at all. If we have something where we are first running removing of special characters and then chunking the words, and in the other option, we are first chunking the words and then removing the special characters. Well, there is a difference in which different vocabulary that we get in each case. If we are first removing the special characters and replacing them with spaces, then we get a different vocabulary. But if we are first doing that chunking, we will have words with the spaces in them. So it's different types of words, and that we need to pay attention to because our feature space will completely change. And there are so many other things that we just don't keep track of. We might write all of this in code and keep committing, but we don't keep track of which commit has what specific feature unless you're really good with your comments. My comments are usually work in progress, WIP. I don't know how many people have that, but it's pretty common because we are focused on the science and not the engineering and not the reproducibility, because the hope is my next model will be the model and I'm going to just push it into production. So we might record each change in Git, but how do we record an actual run, end-to-end run? So what are we doing right now? How are we managing our ML experiments right now? Like this. We have, most people that I know, a lot of people that I know have an Excel spreadsheet with things that are interesting to them. This is a real one that I showed to a customer a couple years ago with the accuracy, the precision. I don't know if I can, how do I go there? Oh, here it is. Accuracy, precision, recall with a threshold. So the recall threshold we use is 0.5 and precision threshold we use is 0.5. Additional details, you see that I gave up after 4 entries because it's just too tedious to keep track of each and everything that you want to record. And down here, the highlighted thing is actually a bug fix. I found a normalization error, which means normalization is things like stemming, things like converting case-sensitive data into lowercase, so that we're dealing with, capital. The first letter of a sentence often capital, and we don't want to treat that as a separate type of word, so we lowercase everything, and found an error, fixed previous experiments, but of course I didn't run all of those previous experiments because, hey, how can you reproduce each and every one of them and figure out which one had that actual error, because a bunch of them didn't. And each run took over an hour to run. So it's pretty expensive to figure that out and selectively run the ones that you're actually interested in. So this is how the documentation is happening. How are we tracking it in case we need to reproduce something? Usually in folders. Most people that I talk to, they have a nice system where they say, I'm very disciplined about what I want to store. I have my folders and a naming convention associated with the folder. If I want to go back, I can go back to experiment 4 that used TF-IDF, or experiment 5 with TF-IDF and 5,000 features. And it's a very common thing that in every space, that every vertical that you go to and every person that you talk to has their own system to manage their own experiments. The problem is when we go back to it, we may or may not understand it after 6 months or after a year. So make copies of each run that you run, commit each code change to Git, tag it. I'm terrible at tagging it, but a lot of people are really good at tagging each and every experiment they want to go back to. Other things that you can save, train model. Sometimes train models are so big in size, especially if they're multidimensional vectors and they're really large. And so it's not always easy to store a train model. The outputs, again, how big is your test file? If your test file is gigabytes in size, each output would be several gigabytes. And it's hard to store all of that. And the last thing is environment variables. It's not super hard to store that, but we are not very good at making sure that we are running in the right environment. Any questions so far? You guys have been awfully quiet. Raja.
So I could not understand this. Are we talking about these separate folders for each run?
Yeah. This is the ad hoc way in which a lot of people are storing.
So this is the ad hoc way.
Yes, yes.
And are we fundamentally assuming that tools like Git are not viable for this? Because if there is a typically when you're iterating on a machine learning experiment, right? So you would either change the config file, and as you said, maybe the output will of course change. You change the parameters, maybe some XML, some JSON associated with your iteration.
Yeah.
So I would say maybe Git is okay, right? So just check in and see the diff, and then you can see the difference.
Yeah.
I see, there is a desire for maintaining that Excel file full of comments and all of that, but perhaps commits will do the same job. I have also used Azure Machine Learning. Azure Machine Learning has another way of, by default, since it's a more graphical tool, it does it. So are you implying that tools like Git are inherently not suited for iterating?
That's definitely what I'm trying to get at.
Because of perhaps the size of the input and output of the models, are you assuming that every time you're doing, are you saving the intermediate steps as well? Because I'm assuming your training and test sets are the same, so they don't change. Models usually are not that heavy once trained. So
They may or may not be heavy. So the question is Git not enough, right? Can we not?
that is the question.
Yeah, can we just not just save the source code so that we know how to come back to that? The thing is though that the source code that you use for say experiment 4 or 5, you need to go back to Git, tag that specific commit with experiment 4 where you did TF-IDF with 5,000 features. So you need to have that information. You need to specify what the environment was when you ran that. That means which versions of which modules were used with it, which often is a part of Git that you can specify using a requirements file. But more importantly, there's no train model, there's no output that is stored associated with it. And there's no metric, right? You have the code. How well did it do? What was a precision recall AUC?
There can be two things, right? One is the model parameters that you're changing, and you're also mentioning code that is changing, right? So code change, I would not strictly consider that to be a change in the model, right? Or unless the parameters are built into the code and the code is changing.
Well, if the code changes, the train model changes, right? So just a couple slides ago, I talked about these different types of features that you can change, or you can change the algorithm, or you can change the hyperparameter, you can change the pipeline. And that's all embedded in code that you can check into Git, right? You can. That's what we are doing right now. We are. And if we're disciplined enough, we can actually take that Git SHA and put it in this Excel spreadsheet right here. Associated with each experiment is the SHA of that Git. And you know the repo. So you can actually do that.
So it's tricky. This is more than one component that is changing, right? So now it's a disparate, like some could be some pre-processing that is changing, some could be some config that is changing, some, okay.
And
I have
so
a question. The point of ML experiment is reproducibility, right? So why are we storing it? Isn't like if our use case is like reproducibility, then what is use case for storing all different models?
So reproducibility is of different types. So the question is, if it's just reproducibility, why are we storing all of these models? You may or may not want to store models. Like a lot of people don't want to store models, they just want to store the outputs. And they want to analyze the outputs. A lot of people want to take that model and test it on different types of data to see how robust is your model. When there's a, it's unpredictable what kind of query would hit that model. And so you want to figure out that and test it enough going in that your model is much more robust and it's not going to break with certain very obvious queries. So everybody has very, very different use cases based on this. The end goal is, if you did an experiment and you want to go back to that experiment after a week or a month, or you want to share it with somebody else, how do you figure out the end-to-end process of this is how the experiment was run? So that's where the reproducibility comes in. So when you want to evaluate results on something else, that's where you need the output. But the best way is you have everything stored in some way so that you can go back to it quickly.
You are assuming that your data is significant. You were talking about gigabytes, right?
Sorry.
You were saying, when you were saying that your data is going to be gigabytes or something big, right?
It could be gigabytes.
No, I mean, because in that case, Git would not work because the fundamental operation that you need to do to Git is clone.
Yeah.
You try to clone gigas and gigas and gigas, but it will never work.
Git LFS.
That's why I like your folder, because
Yeah.
I can just duplicate or copy a folder.
Yeah.
Whereas in Git, the unit is in the repo,
Yeah.
so you get everything with all the versions that can be terabytes.
Yeah,
And
yeah.
cloning that is crazy.
So yeah, if there's lots of data, then Git doesn't work. If the model is too big, Git doesn't work.
For everything that should work, Git works well. Out of the data.
Well, so Git LFS is the way in which large file storage. I think that's the Git version to do that. But if you have like 5 versions of the file, because it's a binary file, there's no easy way to have those diffs between 2 different files. So the entire files are swapped out. In which case we get to that.
The notes per version.
Yeah, but as you
you do that in software, like a cake,
Right.
note, have all those indications that
right,
have
pictures
size
and
is
video.
huge.
Right,
It's
right.
a big piece.
So when
I think you're right.
that happens, it's a big problem. But the issues with storing this folder-based approach, storing in a folder-based approach is there's no nice separation of code and outputs and metrics. There's no side-by-side comparison of code. Like Git does that, and if you keep track of the SHAs that you're interested in, you can do that side-by-side comparison. Of course, it's kind of tedious because you have to do git diff and have that SHA-1 and SHA-2. It's not like a one-click thing where you can select experiment 1 and 5 and say, how is it different? No side-by-side comparison of metrics. And then you can't really store models and other artifacts. So for instance, for a training algorithm, you need 5 other models that are taken in. For instance, word2vec is a model. You'd use a trained model of word2vec for that example that I shared. And so that's a prerequisite. That's an artifact. How do you store those artifacts? This word2vec model is a gigabyte in size. So what do you do with that? And how do you figure out that I used version 1 of artifact and version 5 of artifact? So there's a lot of versioning that comes into that as well. And then there's environment variables. Then we're usually not very disciplined and deliberate about storing all of these. And so I'm not the only one who has this problem. I'm sure not everybody has this problem, but there are enough people to have this problem to warrant a discussion about it, to figure out what's the best solution. Some verbatim comments from others in the community. I just don't understand how they got that result. This is a pretty common one. I thought I used the same parameters, but I'm getting different results. This is actually also in academia, where you're a reviewer in a conference, and we have these discussions with other reviewers, and people are, I couldn't get that exact result. I saw the GitHub repo, you clone it, you try to run it, it doesn't work. And so other people misquote that research to say, well, that gave us 20% accuracy, and our research is better because we're getting 90% accuracy. And this happens all the time, way more common than I'd like to admit. I can't remember which version of the code I used to generate figure 6. The new employee wants to reuse the analysis I published 3 years ago, but he can't reproduce the figures. It worked yesterday. This is very common. In academia, there's things like materials and method section doesn't explain how the results were normalized. Description in the results section is different from what's in the supplemental material. I'm sure I'm using the same parameters as the original authors, but I just can't get it to work. So why? Because reproducibility is hard. It's not only dependent on code. There's code, and within the code you have scripts and names and versions and options and dependencies. You have the input data and the output, and then there are other things like machines, the processors and available memory and the operating system. It worked on Linux, but it's not working on Windows. It's not working on Mac. Data logs and outputs. Where did it run? When did it run? Who ran it? What was the purpose? And a lot of other things. So coming back to this, there is some kind of disconnect. Yeah.
You said reproducing code, but isn't it more reproducing code outcome? Then it's hard to.
It could be both, right? So reproducing code for training and evaluation. So there, with every machine learning thing, if you want to reproduce a model, you won't get to that exact same model in most cases, and you could often be stuck at a local minima instead of a global minima. But if you want to retrain that process or run that training process again, then you're reproducing the training code. And then evaluation thing as well, where you want to use that model or you want to use the outcome of the new model to evaluate on a test data set. So both types. ML is quite different from software engineering. Software engineering is much more structured, where we have specifications, and then we design, we verify, we deploy, and done. And then we have new specifications, so we build on top of that, and it's a much more sequential thing. And Git is perfect for that, because it assumes that the master branch, or there's a final branch that you want to get to, which is the best branch, and that's what we'd use for deployment. Machine learning is not that simple, because you keep going back and you keep iterating on your testing data sets using different algorithms. You are focused on the evaluation, and this process just keeps going on. And Git isn't the best way to store it, because you can have experiment 1 and experiment 2 and 3 and 4 and 5 all in a sequence, but that doesn't tell you that experiment 1 is better than experiment 5. And so we need some kind of a parallel way in which we can store all of this parallelly. Deploy the code to Git, and Git is still the best way to manage all your code. But then there's other things where we are managing experiments and managing outcomes and managing metrics and results. Any questions so far? Is everybody on board with the actual problem space that we are addressing?
It seems to me that, like, when you do machine learning, there is no one set code. You create a code, there's a result, and then you need to create a new code. Like if the machine is learning,
it's not usually completely different code. So you are optimizing and you're figuring out what are the best. It's just few things that you would change. You would not change everything. So for instance, I was talking to Arthur a little while ago, and he's talking about architectures, deep learning architectures. And when you're doing deep learning, you change the architectures and the hyperparameters a lot, and that's what you work with. If you're doing standard machine learning with scikit-learn, you would do feature engineering. So the majority of your time is spent on engineering the right features so that your model is trained. But you don't completely switch out your code and write completely different code. That's usually not what happens in ML. Yeah.
I'm not an expert, but for the few things I did, many of those things can be done like in software engineering. And probably you can criticize me, okay? But you have like an initial data set, and you can do all those transformations through code. And then you can, when you do, like you say, you can deploy all the running through code because it's infrastructure as code that you run on the cloud, and you can get, all the outputs, and you can keep that, and that can keep it on Git, and keep versioning, and see all the differences, and also see the addition of that.
I agree with you, and that's what we've been doing so far. No question about it. Like, we are using Git for everything. We are using scripts for like pre-processing and everything, and we are storing some models, not all the models, and it's okay because most people are saying, I did it last week. I know it didn't perform well. I'm not going to go back to it, unless my boss is on me, in which case, okay, I'll rerun it again if you're telling me to. But there's no accountability in that sense. You've done that experiment before. You could just do a one-click and get back to that experiment. So I agree with you. That's what we're doing. We're using Git for source control and scripts and everything, and that's the state of the art for machine learning. Any other comments, questions? So, tools, some basic tools to do in order to write reproducible code. The first and foremost is write robust and reproducible code. And what does that mean? Your code should be super modular. You write tests for your code. Most data scientists do not write tests for our code. We do test our code, but there are no tests that are properly written, no unit tests that are written. We don't know what's the coverage of code. We don't know how many, what percentage of our entire code base is actually tested and has test suites written for it. Work in virtual environments. They are super cool because now we know all the dependencies that we need in order to run our code. If you're using just one language like Python, and a bunch of my examples are based on that, virtual environments are built in Python 3. And so as Python 2.7 is deprecated, so you can very easily spin up a virtual env on your machine, and you've kept track of all the modules that you need for your system to run. And lastly, design your code to be easily understood by others, where others could also mean you in 6 months, which everybody, including me, we are terrible at it. So what does it mean to make code modular? And this is a gross simplification. But if you find yourself repeating or duplicating your code, just take that and make it into a separate function. It's a very simple example. The train and test both have a file opening system where it's loading it using JSON. Now say for instance you got a new file which is a CSV file. You'll have to find each and every place where you need to change that, and that leads to bugs, and that leads to errors and reproducibility issues. Well, just take that out and make it into get data from JSON, and that's the function that you call every time you want to open a new file. Super simple, super modular, but this way you know that when there's a bug in one function, and if you have some tracking that tells you all the experiments that use that one function, you just know that one click you need to run all of those experiments again because they used a specific function. Automated testing. Everybody hates that. Everybody who's a data scientist hates that. I'm rephrasing it. We do test our data. I mean, we do test. We make sure that it runs with certain examples, but we don't have all of these tests written out. So all the tests that you were performing manually before, write them in a script. It gives you the confidence that your code is doing what you think it is doing, and then you can free up your time to focus on the science as opposed to worrying about changing something so that it doesn't break your code again. And if you do break your code, your test will tell you immediately that this is broken and fix that. There's a lot of initial time investment, especially learning which test suite do you want to use. But once you get the hang of it, which is maybe in an hour or so, it's so easy and so much more convenient, especially as you are reproducing your code and somebody else is running your code and they figure out that, well, there's this library that's missing because this specific test case is not working. quick example of nose tests. If you're using Python, which most people do for machine learning and deep learning, nose has a nice way in which you can figure out if you have specified the width coverage flag and tell them the package that you want to run. It'll tell you how much of your code is actually covered. Like there's a 30% coverage in my main file. That means I need to write way more tests to fix that. But having tests helps when you are moving from one machine to the other, one person to the other, somebody else is running your code to make sure all the requirements and all the code is running as is expected to run. Then work with a virtual environment, and I cannot emphasize this enough because this is it's such a life changer when you work with a virtual env. Python has a very lightweight virtual env, and it's this simple command: Python 3-m venv, which creates env or whatever that name that you provide as a virtual environment. You can get into that, activate that virtual environment, and then install all the requirements that you have using pip. Pip is requirements.txt is another thing which is part of this whole virtual environment system. That if you have requirements explicitly specified, which look something like this, you're saying these are the 5 modules I need, and this specific version is what I need. Not just these modules, because they keep changing. People who are managing the modules keep changing. Your code is dependent on these because you have tested it on these, and these were installed in the machine on which you ran your training and your testing and everything else. So we cannot settle for these different versions. And this is super simple. How do you get that? Well, just type pip freeze on your machine, and you will get all the components that were installed and the versions that were installed. And if you probably don't need all of them, right? You need selected ones that you're using in your code. So pip freeze and then grep for the actual name. If you're using scikit-learn on it, grep for that. If you're using PyTorch, grep PyTorch, and it'll tell you PyTorch with that version. So you can add that in your requirements file, spin up a virtual environment, and voila, your code is ready to go to somebody else who can do the same thing and get the exact same libraries that you wanted to get. Any question, Rajan?
So maybe I'm getting impatient, but I think this is interesting here. So are you suggesting that for each iteration of a machine learning model,
no, it's a one-time
thing. Creating a virtual environment, or it's just a Python best practice, right? So I'm aware of that, but you're not suggesting that for each iteration we are actually creating a
that doesn't
model
make
iteration
sense.
1, it's V and V1.
No. Just having that up front, having test cases up front, and having a virtual environment up front, because there's no overhead to that. So for example, experiment 2 has 3 new dependencies, right? Creating a whole new virtual environment for these 3 additional dependencies doesn't make sense. You can have one virtual environment, but that will still be smaller than your entire PC, right? All the things that are on your machine. So just one, but having that makes it so if you're writing code and you give it to me, right, I can just look at the virtual environment that you created, and you don't even need to give me that virtual environment. I can recreate that with the right requirements and everything. But once you specify this requirements file to me, I can duplicate what you had. And this is only for Python. If you are have dependencies between Python and other code, use Docker, which is a little more heavier, and that gets into this whole engineering space. But there are other ways to do that, other ways to create these containers and other ways to create these virtual environments so that you can share your code and share your data with other people. And finally, ensure your code is easily understood by others. So have documentation and have comments in it so that it's easy to understand. So now that you've done all of this, you have this beautifully written package with documentation, with test cases, with virtual environment. What's next? Start with some open source tracking software. And I've been studying this for a while, and it's a lot to get into, so I have summarized as much as I can, and we can get into details of things in a bit. But there are so many experiment management systems that are available right now for free and well managed and well maintained for you to try. My favorite one is guild.ai. That's the link, and feel free to take a picture if you want. And so there are two basic ways in which experiments are managed. Some people like the command line option. Right here, the top three are the command line options, and the bottom four are immersive. Now, what's the difference between an immersive and a command line option? Command line ways of running code is something like this. All you have to do is type in guild run train.py, and it knows that it needs to run this specific file. It will run it, it will store all the metrics all through command line. If you do immersive, then you are asked to import an API that these guys have created, like Sacred, and then you can do it. You have a little more flexibility with things like experiment.send, and you're sending these things, or experiment.record, and it'll record whatever variables you want to record or variables you want to monitor. There are lots of advantages and disadvantages of either, and I guess it is based on personal preference of what you like. Would you like to remember these different command line options, or would you like to learn a whole new API? And that's up to you. Yeah.
Because they are open source, which one has the strongest community?
Which one has the strongest community?
It's a good indication, the one that is more supported, better managed, and so on.
Then none of them do at this point have a strong community. So MLflow, that comes from Databricks. There was actually a talk about that yesterday. And so that is, they are trying to market it really well. And then there is Sumatra, which is, there's Sacred, which is used by a specific university, and they're trying to grow it from there. With the interesting thing is, when you look at the code on GitHub, if you look at who the contributors are, for most of them, there's just one contributor. There are others, one main contributor. There are others, but there's just tiny bug fixes here and there. So there's not enough confidence as such that there's one clear winner. And that's the case for paid software as well. There's no one clear winner yet. So right now, it's about you and your convenience and your individual management of data, because none of them actually have a server option. If you want to say your machine doesn't have enough juice to store everything, you're out of luck, unless you have a server where you can push your MLflow metrics to, and you need to set that up yourself. So this is good for individual tracking. You can still go back to your different experiments end to end, and I prefer Guild as one of, I see that it's been managed every single day, although same thing, written by one person who is constantly at it for almost 4 years. Studio ML, not managed that much, which is a third option from the top, so I wouldn't use that. But it's still up in the air, like we don't know which one would be picked up and then starting to be maintained.
So I'm not familiar with any of them, so I'm just curious. So when you change, when you make changes to machine learning pipeline, so broadly, if I want to classify, there may be changes in your data, there may be changes in the way you do feature engineering, any missing values, dropping other things. There could be changes in configuration. You've made some changes to some config, some parameter, some hyperparameter, right? It could be some changes in the code, right? Does it sit on top of your source control?
Yeah.
How does it?
Most of them work with Git, or I think they all work with Git. There's a couple of them said they might support Mercurial, but I don't know why they would, because there's just 1 or 2 people who use it. But most of them work with Git, and they want to make sure that you are using the right SHA associated with the experiment. However, like tools like Guild AI, what they do is just work with your code, and their reasoning for that is any change you make, you may or may not commit to Git. So it may or may not have a SHA associated with it. If you want to do config files, and if you want to change config files outside of Git, you can use a Git SHA and just keep changing your config file and store each experiment. That's also doable. But everybody has a very different way of running code. Some people use Jupyter notebooks, in which case command line options don't work at all. They want to do something that's much more immersive, because they want to run each cell one at a time. So although yes, they work with source control, they have, a few of them have options to not work with, say, source control.
Sure. So I don't know how to put it correctly here. So because technically, if I'm using this GIL, for instance, or any of these to manage my experiment, do I need Git after this? Is it built on top of Git? Because think about this, that changes in experiment are more than source, right? So Git control, Git versions.
I think I know. Yeah. So you're asking about a server component to all of these, like Git or GitHub, right? Is where you store all your source code, and this will store each run of your experiment. But where is that stored?
Actually, that's not what my question. What I'm trying to say here is, this is sitting. This is doing more than what Git could do for you, right? So, and you know, it's so. First thing is, if I'm let's say if I'm a machine learning engineer, I'm trying to version my experiments. Would I still need a Git repository, or one of these will actually track all the config changes and all the code changes for me, and I will see the versions of my experiment instead of code in here?
Yeah, a lot of them support no Git. You don't really need Git. Yeah, but if you have Git, some of them also support that. So if you have Git, it'll clone your repo, it'll run it for you, and it'll associate a SHA with your code. So.
And are these also similar in Git, that in Git, if I want to, if I'm tracking some files, I'm ignoring some files, right? In this case, you identify stuff that you want to track versus not track. Let's say I'm not interested in some intermediate file that my model spits out.
You can specify what you want to track. So it's not really tracking source control. It's not doing source control like Git. Like, it won't tell you this is how these two are different. It will track the end-to-end experiment, and different ones of these will track different things. So if it's immersive, you have way more control of what you want to send or what you want to store. You could just store the final outcome, a final metric, or you could store the model, or you can store the data SHA if you're changing the data a lot. So it's up to you, and because there's no specific way in which ML is done. You as an ML practitioner need to figure out, what do I need end to end in order to go back to that experiment.
Yeah. In Git, for instance, if I don't ignore anything, if I say Git at all, right? So it tracks everything, right?
Yeah.
So everything becomes tracked. I'm
Yeah.
assuming that it would be something like that, right? So that you are selectively deciding what to track and what not to.
Yeah, but see, it's beyond source. So because comparing it with Git I mean, we can't replace Git in any way, because Git stores our source control. It has all the source. This is more about end to end, and this is more about evaluation. This is more about metric. It's about how does this source SHA work as compared to this other SHA, right? And it's not only the difference in code, it's a difference in actual evaluation.
I totally get that.
Right.
One more thing. Does it only work with specific libraries? Because traditionally Git would, anything that is output and exists physically in on the disk, right? That would be tracked. Mm-hmm. I'm assuming that in some cases, my Python model is an object. Mm-hmm. And that object has some other objects that have other objects, and they have some. My confusion matrix is not printed or stored in a disk. Yeah. It is in a model. So I'm assuming that it is tracking any changes of the objects that are spit out.
So very good question. So when you're running code, you have objects, you have variables, you have things that change. And so if you use an immersive library like Datmo or ModelChimp or MLflow, you can import this MLflow model and then use that to track whatever you want to track with that. So it gives you that flexibility to say, this is the model one that is learned, and so instead of dumping it into a pickle file, you just send it to mlflow.track or whatever the syntax is in the API. With command line tools, you need to actually explicitly specify that track these files, and save these files for reproducibility. So there's that
beautiful
difference.
stuff. I mean, so I was not aware, so this is native. And I'm assuming you can do versioning, I mean, so you can see how they progressed and how a certain object changed over time. I can feed in metrics, my accuracy, you can see over time.
Yes, yeah, you can have a visual display of most of these things. Although the visualization is supported way more in these paid tools as opposed to the free versions. So a quick comparison between command line tools and immersive tools. Command line tools are totally independent of programming language. You can use Python or MATLAB or R or whatever you want to do, but immersive are very coupled to, most of them are Python actually. In fact, all of them are Python. I have not come across any immersive tool which does not need Python. Command line has much more freedom for you to code exactly the way you do, because all you need to do is use their tool to run your code and change the config file. Whereas with immersive, you need to edit your code to say importing their library and tracking their metric using their library and so on. So you get freedom to about what you track, but it needs to be within the code and it goes to GitHub and all the source control that you do. Command line, you need to learn command line arguments, what arguments you need to provide. For immersive, you need to learn their API. So there's still a little bit of a learning curve in both cases, and based on your style, you need to figure out which one you like, which one you don't. And so going back to the outline, I think we're running a little bit out of time now, but the last thing I want to talk about is paid software. There are a lot coming out. I just listed 5 or 6, which are the incumbents, or I don't know if I should call them incumbents, but they are trying to get into the space. There's Comet ML. In fact, all of them are immersive. Determined AI does a little bit of command line arguments, but most of them are for Python. They're immersive. You need to import their library. And all of them provide a server interface where you run your code and it's automatically, the metrics are sent to the server. The slight drawback is that wherever you're running your code, it should have internet access. And if you're running it on a server which does not have HTTP port open, then you're probably out of luck unless you have a on-premise installation of their specific system. Most of them are targeted towards startups and individuals. Comet, Neptune, Weights and Biases. Weights and Biases have a very good free program, so if you want to try it out, that they have much more flexibility in that. And there are new ones coming out every single day. So this is a problem that people are starting to face as there are more ML people coming into this world, coming into this business world and practicing ML on a daily basis. So I would encourage you to try them out and see if there's anything that works for you if you're facing this problem. Nothing is a clear leader yet, and it's hard to understand why or why not, because it's still fixing this intermediate problem of tracking experiments, but we don't know which ones we should discard, and we don't know which ones we should keep, and we don't know what we should keep. And so in a sense, it's like storing cord blood for your kid. I don't know how many people are familiar with that, but when your kid is born, you pay money to store cord blood for your kid. You may or may not need that. You hope you don't need that, but you're paying money every year to track that, and this is kind of similar to that. You hope you don't need your old models because you want to learn new models, you want to train new models, but then you pay them a monthly fee per person, per institution to track your models. So jury's still out there.
Short question. How much value do you see in the tools compared with classic software engineering? How much value do you see all these tools compared with more classic ways? Because there is a very well-known body of knowledge about how to build pipelines, how to deploy pipelines, how to automatically run things in cloud environments. So that's a body of software engineering that everybody uses, and there's a ton of tools outside. Do you see more value using some of these tools, or do you believe that all the other tools that are used for other systems can be used also?
It depends. Is there any value in these tools? I don't know. I feel like it depends on the problem that you're solving. if you have so many iterations in a certain problem, it's so helpful to have a tool that will just manage everything for you, or take you schedule all of these runs and it'll run everything for you and come back with all of these metrics. So you don't need to do anything because it does the work for you. But if it's a smaller problem and it takes like 5 seconds to run, or even 5 minutes to run, I won't bother with this. I mean, it's such a pain to have all of this like tracked, and then there are 100 models for each problem, and then I need to compare, and it's a pain. So it depends on the problem. Conclusion, TLDR is ML process. We don't have any predefined guidelines like software engineering or writing code. So best practices for that we can take from software engineering is write modular code, write test cases, use virtual environments. The last one, I would say always do that. It's just so much easier to reproduce code. And when you're ready, start using some open source tools to manage your experiments. And when you outgrow that, let's get into the paid space and figure out these server-based tools to track all experiments. And that's it. Any questions?
Are you going to give us the
Slides?
slides?
Yeah, sure. I'm happy to share the slides.
Yeah.
And there will be a video available.
Online?
Yeah. I can, I'll give your email after
Yes,
this.
I have signed up there.
Oh yeah,
so
yeah, I can do that too. I'll just send you all the links. So
please follow up.
yeah,
That would be great.
I think it'll be ready on Monday.
Yeah, no rush. You can be ready on Tuesday since Monday's
Okay.
So perhaps if you look at this, if I'm going through 10, 15, 20, 100 iterations of a model, there's almost, I think there will be a natural desire to actually visualize this. So how about in an ideal world if you can, perhaps there's some sort of XML or JSON that I get that's continually being updated with all the model values. The objects are there, everything.
Yeah, most of
And
them
if
do
I
that.
want to
Yeah.
really visualize and see some sort of,
Loss function.
try to understand what happened, right? So
Yeah.
just sort of hindsight analysis.
Yeah.
When I moved my parameter like this,
Uh-huh.
this was the impact.
Yeah.
Is there anything?
Yeah, most of them do that. Like how your training happened and what's the loss function and whatever variables that you care about, intermediate variables, they do that.
And one more thing, I mean, I'm more of an art person, so is there such a thing for art?
Not immersive, but it is, the command line ones have that. So in that, if you specify in the config file that track this specific file, and in that file you can keep dumping the values that you're interested in, like in a JSON file or something, and it'll keep polling it every second or every X duration of time to build that graph for you.
Okay.
Any other questions? I didn't put my email there, but you're welcome to email me as well if you have any questions. It's just me@rutumulkar.com. So feel free. Me at my Twitter handle.com.
Okay.
Yeah.
I was just wondering, especially if you're working for a client that has some sensitive data, like you work in the medical industry, health industry. How do you go about protecting this data with these tools that are like Git is connected to the cloud, and
Yeah, usually it's all on-prem, which is on-premise. So your company would have their own cloud and their own version of GitHub, which is hosted in the company, and nobody else knows about that. And so are these tools. Some of them have on-prem installations available, so everything stays within your company and not really on the cloud. Although the solutions are the same as that are available on the cloud, but they're not accessible from the cloud.
Right. Okay, thank you.
Yep.
All right.
Thank you very much.
All right, thank you so much. You're a great audience.